What's up, everybody? What's up? What's up? Welcome to another TallTal video. Today, rock stars of the mathematic universe, we are going to be focusing on order of operations, but not the intro to order of operations. We're going to use what we know about order of operations when someone gives you us the replacement value for a variable. That may sound like a bunch of gobbledygook, a doog, but I'm going to explain it to you, and it's going to be a lot easier than what I just said. Okay? Do you know what kind of bears don't have teeth? Gummy bears. Oh, the gummy bears. All right, so what's our target? This should be a pretty brief video. There's a little bit of solving of these replacement variable order of expressions, but it's kind of a review on order of operations and then a simple replacement kind of idea. Like when we give a variable, what if they tell us what the variable represents, and then we just use order of operations? And so if you're struggling with order of operations, go back and watch that video. But today we're going to use what we already know to evaluate algebraic expressions when we're given the replacement value. Okay, so let's just real quick, let's remember what order of operations is, order of operations are, and that's kind of what we use the phrase GEM does. And you may have heard PEM does, but we use GEM does because the G stands for groupings. PEM does uses parentheses, while GEM does, yeah, that includes parentheses, it includes absolute value, it includes brackets. So we've changed it to GEM does for the G. So that's the first thing you do. When you see an expression and it's got all different kinds of things that can happen, we focus on the G first and we look and see if we have any groupings. And when we say groupings, there has to be something inside that grouping that needs to be solved. Because we also know that we can use parentheses to show multiplication. And if it's just 3 times parentheses negative 3 parentheses, then that's just a multiplication. We can't do anything than a negative 3. It's just sitting there. So after we do groupings, then we look for, do we have any exponents or radical expressions? Meaning, do we have anything with an exponent involved, 4 to the third, or do we have anything with a square root symbol? And if we do that next. And if we don't, we skip on to the next one, which is M and D, which is the multiply and divide. And this means we do whichever one of those we see following another rule called the left to right, or how do you read a book? You start at the left and you move to the right. So we look for any multiplication or division, and then we do whichever one we see first from going left to right. And then finally, the last 2 letters are the A and the S, which are for addition and subtraction, and we follow the same rules as we did for multiplication. Look and see which one you see first, going from left to right. So we're going to use all that, but we're going to bring variables in. In the previous video on order operations, there was no variables or letters. It was just all numbers. So now we're going to have expressions that contain a variable, but the kicker is we're just going to go ahead and tell you what that variable stands for so you can throw a number in, all right? For example, if I have 3 plus x, okay, and then they tell us where x equals 5. So all we do is we substitute or we replace the x with what its value is. So we get rid of that x, and then we move that 5 in there. So what we really have is 3 plus 5, and our order of operations, well, there's only one thing you can do, so it's addition. So we just say what is 3 plus 5, and it equals 8. Okay, so that was obviously a real generic, easy version of that. So right now what we're going to do is focus on maybe one that's a little bit more challenging. Okay. Okay, so now we're given a little bit more complicated of a situation because we're going to have to substitute in for multiple variables, and then we're going to use order of operations to solve. So let's go ahead and look at this. We have 3x minus 2y times 3. Okay, it's telling us that x equals 2. So let's go in and rewrite this. We have 3. Remember, the x represents 2, but when we started, these guys were touching, which means they are multiplied together. So we have to put the multiplication symbol in there as we put our 2 in. And then we go ahead and write our minus, and we have 2, and the y is represented by 1. So we're going to go ahead and put the 1 there. And remember, it was multiplication here too as well, so we have to put that multiplication symbol in. And then we go and we write our 3. Okay? So now we're going to use our GEMDAs, order of operations. We're going to go, do we have any groupings? Well, there are not any. There's no parentheses or brackets or absolute value. Do you see any exponents? Nope, there's no exponents. Do you see any multiplication or division? In this case, yes, we do. We see it twice, okay? So we do our left to right rule, and we say, let's do this one first. What's 3 times 2? Well, that is 6, okay? Then we write everything else back down, and we know that we have some more multiplication to do. So we say, okay, we have 2 times 1 times 3. So let's go ahead and do this one. That equals 2. And we write everything back down. Okay. We have another multiplication that we can do. So we do that next. 2 times 3 is 6. And so we have 6 minus 6. And then when we say 6 minus 6, that's the last thing we can do, and that would equal 0. So we used the replacement values, we plugged them in, and then we did GIMDAs, which was, there was no groupings, there was no exponents, we did all the multiplications, there was no division, and then we looked for addition and subtraction, and there was no addition, so we did subtraction. All right, let's go to the next one. This one's got some groupings in it, maybe a little bit more difficult. So we take our original value and we say 3 times x. This time x equals negative 2. So I'm going to go ahead and put my multiplication sign and I'm going to put negative 2. And it's going to say minus, okay, minus. So we have absolute value of 2 times y. Now y equals a negative 5. So we're going to go over here and we're going to put times negative 5. And then we bring down our multiply by 2. So we go back to GIMDAs and we say, what do we see? Do we see any groupings? Yes. So absolute value is groupings, okay? And so we want to make sure that we start with that. We have a grouping, we have absolute value. So we have to solve everything that's inside the grouping before we do anything with the grouping, okay? So we're going to take this and we're going to say we have 2 times negative 5. What is 2 times negative 5? Well, it's negative 10. All right, now remember, the absolute value tells us to do something, so we're not done with the absolute value sign, or absolute value bars, so we write them back down again. All right, and then we say, what do? We still have a grouping, and there's something to do inside the grouping because it's the absolute value of negative 10. And the absolute value of negative 10 simply tells us how far is negative 10 away from 0. So this comes down and becomes 10. Okay, then we write everything back down. Remember, we're just going to make sure we don't mess up this problem by skipping any steps. Now, do we have any exponents? No, we do not. Do we have any multiplication or division? Yes, we do. So we go left to right. What is 3 times negative 2? It is negative 6. Write everything else down. Okay, now do we have any multiplication or division left? Yes, we do. We have negative 10. We have negative 10 times 2. Well, 2 groups of negative 10 would give us a negative 20. Okay, then we bring everything else back down. And remember, this is negative 20, the answer. So we have to, whoops, I don't know why I did that. When we bring down the negative 20, that's the value right there. So now we have 10 minus 20. Okay, 10 minus, or I'm sorry, 6 minus, negative 6 minus 20. So if I have negative 6 and I lose 20 more, or if I've lost $6 and I lose 20 more dollars, I've lost a total of $26, or I have negative 26. Negative 26. Okay, let's go try another one. They're just going to get a little bit harder each time, y'all, a little bit harder each time. So now we have another expression, but we have some different values. So now we're going to go 1/4, but we have to plug in this c for the 2, okay? And r is going to be negative 6. So we have 1/4, parentheses, c represents 2, plus r, which represents negative 6, times 2, okay? And so now we've got ourselves an expression that we can solve using order of operations. Okay, what do we do first? GIMDAs. Well, we see there's parentheses involved. And once we're inside those parentheses, we have to use GIMDAs again. Are there any other parentheses? No. Are there any other exponents? Yes. So we have to do this first. Now remember, we are going to keep these parentheses involved until we are completely done with this problem, okay? With everything inside of the parentheses. So 2 squared means 2 to the power of 2, which equals 4. And then we bring down everything else. All right, and we're still going to use GIMDAs. We have an addition and we have a multiplication inside there. Well, we're going to do the multiplication next, okay, because we don't have any more exponents or groupings. And so now we have 1/4, parentheses 4, plus, what is negative 6 times 2? Negative 6 times 2 is negative 12. We still have something inside the parentheses we can do, so we keep them there. And so we have 1/4. What is 4 plus a negative 12? That's going to give us negative 8. Okay, so now we have 1/4 touching a parentheses, negative 8. So that means multiply, doesn't it? And what is 1/4 times 8? Well, we can go up here and say we have a fraction, times a whole number, so we can turn that whole number into a fraction. I'm sorry, it's negative 8. And then we simply, can we simplify diagonally? Okay, can we simplify diagonally? Yes, we can. We can turn 8, 8 and 4 have a number that will go into both of them, and it's 4. So 4 will go into 4 one time, so that becomes 1. And 4 will go into negative 8, negative 2. Okay, so now we multiply across and we get 1 times negative 2 equals negative 2, and 1 times 1 is 1. So that answer is negative 2. And we are done. Substitute in, do order of operations. All right, let's do the last one. Holy macaroni and cheese, this one looks difficult. It's not as hard as you think. But remember, from order of operations, when you have a fraction involved or a giant expression on top of a fraction and an expression on the bottom, solve each one of them before you move forward, okay? So we have to solve the top, and then we have to divide it by the value of the bottom. So do you see any parentheses? Yes, we do. Let's go, well, first of all, let's go ahead and rewrite this, but plug in our values. 50 minus h, and h equals a negative 10. So this is where you got to be real careful. It has a negative sign or a minus sign already there, and it's telling us that h equals negative 10. So you have to put another negative sign in because that, or another negative sign in because that's what h equals. H equals negative 10. So the value of whatever this new h is going to be subtracted. All right, so 50 minus the value of h, which was negative 10. So then we put plus, and we put square root of 25 times 2 times r. Okay, so we have 2 times r. Okay, and r represented 2. And then we go down here and do the bottom, and we have the square root of 16. So plug 16 in for c. All right, so now let's focus on doing the top and bottom separately, and then we'll do the division at the very end because we're going to divide those two expressions. All right, so let's look at the very top. Looks like I forgot a parentheses right here. So it's good to always go back and look and see, did I write everything down right when I substituted my values? Okay, so inside that parentheses, is there anything we can do? Yes, there is. I can go ahead and do the exponent because that would be next in line. Okay, so I'm going to say 50 minus a negative 10 plus, what is the square root of 25? It is 5. Okay, keep our parentheses because we're not done, times 2 times 2. Okay, now inside this parentheses, we don't have any addition or subtraction. Now notice I'm just leaving this alone right now because we're going to do that one at the very end, this bottom of the expression. So 50, so we have inside the parentheses, we have an addition subtraction. Okay, so we do them in order that we see them. All right, so remember when we subtract and we have negative numbers involved, we go ahead and switch the last two signs, and 50, now we got 50 plus 10 equals 60. Okay, so we're still not done. We write everything else down. Okay, now inside that, we only have an addition problem left, so we have 60 plus 5, which equals 65, times 2 times 2. Now the parentheses is gone, so we go back to our order of operations. Do we see any groupings? No. Do we see any exponents? No. Do we see any multiplication or division? Yes. We have 2 of them here, okay? So 65 times 2, so you're going to double 65, which is going to give us 130. 2 groups of 60 is 120. 2 groups of 5 is 10. You add them together. And then finally we say, oh, we got 130 times 2. Well, we're going to double that hundreds and get 200. And we're going to double that 30 and get 60. So now we know the top of this equals 260. Okay, I'm going to get rid of that. I kind of put a dash there just to show, but I want to get rid of that because it makes it look negative, right? So the top is equal to 260. And the bottom only has one thing we need to do here, right? What is the square root of 16? Well, the square root of 16 is 4. So now we go in and say, can we divide 260 divided by 4? Okay, so 260 divided by 4, if you're using a calculator, if you're allowed. If you're not allowed, then you got to go ahead and do the long division. And how many groups will go into 260? Well, I'm going to do it up here. I'm going to do it up here and say we got 260 divided by 4. So I know that 6 times 4 is 24, and I subtract, and I get 2 left over. And then how many times will 4 go into 20? It is 5. So our answer is 65. Told you that one's a little tricky. All right, just got to substitute, take your time. To be honest, where most people mess up on this is how many steps there are. They forget to bring a negative sign down, or they forget that they're still in the parentheses, or they make a simple mistake in their calculations at the beginning of it. And when you do that, you kind of ruin your chance of getting things right. So be real careful. Draw those little dashes. Remember, like if I had 4 times 3 plus 2, and I was going to do the multiplication first, you may have noticed I did that every time so I could see, just kind of go back and track what I was working on. And then I would be able to say, I see I did this, and then I did this, and then I got to this. So write down your work. Be super careful. Don't try to do all this in your head because it's a lot of steps and you will mess that up. Okay. And then you're going to be tired like a chicken. And do you guys know what a chicken does when they get tired? And you know why they get so tired? Because they were working around the cluck. Cluck. That's a chicken sound.